Okay, this is the last video lesson of Chapter 8, Section 8.8, Factoring by Grouping. And in this lesson, we're going to factor higher degree polynomials by grouping. So these are only specific ones that can be factored by grouping. And by grouping is just what we've been doing the whole time. So again, this is the same exact method we've been using. For all of Chapter 8, we've really been just using this one method to factor. So let's just look at this. You can see we have 4 terms now. See, it's higher degree, meaning this is a third degree polynomial. So this is third term, second, first, 0. And so the 2 middle terms aren't combined like terms. Or you don't have to combine them because they're not like terms. So we can just go right into the factoring by grouping. So you factor the first 2 by GCF. Here you can see you have a, this is a 3, and this is a 3 and a 4, which is a 2 and a 2. So they have a 3 in common. They also have 3 n's and 2 n's. So 2 n's are the ones that are the common. So you can pull out, so the GCF here is the 3n squared. So then you can pull out the, divide 3n cubed by 3n squared, you're just left with an n. And if you pull out a 3n squared on the 12n squared, you get a -4. Okay, and then here, we'll pull out a GCF. They have nothing in common, right? Oh, they do, a 2, sorry. They both share a 2. So we're going to pull out a 2. And then if you divide this by 2, you get an n. Divide this by 2, you get -4. And so this only works, so remember again, when these 2 match. So one of our factors is n minus 4. And if you pull that out, you're left with the 3n squared plus 2. So this is really just all we've been doing. It's just higher degree. So that's it. So try this next one on your own. Press pause and then check back for the solution. Okay, hopefully you got 8t squared plus 5 times t plus 2. It's because the GCF of these 2 was 8t squared, which left t plus 2, and then the GCF of these 2 was 5, which left t plus 2. Pull out the t plus 2, and you're left with 8t squared plus 5. Okay, moving on to the next one, we're going to do the same thing. But the same thing in that in this one you can see they all have a q and they all have a 2 because they're all even, right? So just like before, we always want to pull out the GCF first. A lot of times with these there isn't one, and so I kind of brush over it and I don't say that, but always when you're doing these, look for the GCF first. So in this case we have, if you looked here, right, 2 and 2, this is 2 and 5, so we only have a 2 in common here. This also has a 2. 8, this has a 2 and a 20, and then this has just one q. So this has a q, this has a q, and this has a q. So our GCF here is 2q. So we're going to pull that out first, 2q. So divide this by 2q, we're left with 2q to the third. Divide this by 2q, we're left with minus 5q squared. Divide this by 2q, we're left with 8q. And divide this by 2q, and we're left with minus 20. Okay, and then we're going to factor what's left by grouping, but we're going to leave this 2q on the outside. Okay, so let's not forget that. That's why I like to always keep writing it. Otherwise, you'll just start factoring this here, and then you'll forget that you have this 2q. Okay, so if you leave it in this parentheses like that, then you won't forget. So let's look at these 2 here. The 2 and the 5 don't have anything in common, but they have 2 q's that are in common. So we'll pull out a q squared. We'll be left with 2q and then minus 5. And then we'll pull out, for these 2, it looks like a 4. So plus 4, and we're left with 2q minus 5. Since these 2 are the same, we've done it correctly. And now we just need to pull out, we have our 2q, pull out our 2q minus 5. And then we're just left with our q squared plus 4. And that is the factored form. So don't forget about this GCF piece. It'll make things messy if you don't. Okay, so try this one on your own. Look for GCF, then factor by grouping, and then make sure you leave all your factors. Press pause and then check back for the solution. Okay, hopefully you got that 3h was the GCF. Here, right, they all have at least one h, and they all at least have one 3. So we pull out the 3h, divide each term, and then factor that by grouping, and you're left with 3h times 2h plus 3 times h squared plus 2. Okay, and then here is a word problem. It's basically just asking you to factor it. A rectangular prism has this as its volume. What expressions can represent the dimensions of a prism? Use factoring. So basically you're just factoring this again. This is prime, so there's no GCF. Oh, that's a number, but look, this each has an x. So there's a GCF of x here. So let's pull that out first. And we're left with 6x squared plus 19x plus 15. And then we can see this is squared, so there's not 4 terms. So this is going to be how we factored before. This is going to look something like this. So we take our 15 times our 6, which is 90, and then 19. We could go through all the numbers, but maybe you notice this too. 10 times 9 is 90. So, and 10 plus 9 is 19. So that was a fast one that I noticed. And so our answer is going to look like this. But in order to get there, we have x times, we're going to rewrite 6x squared, our 19 as plus 10x and plus 9x plus 15, and then we'll do our grouping. So this looks like a x, and then 2x is my GCF here. So 3x plus 5, and then a 3 plus 3, 3x plus 5, good. So then one of these terms is 3x plus 5, and the other is 2x plus 3. So that is an expression that can represent the dimensions of a prism, a rectangular prism. It just looks like this. So it's just volume is length times width times height. So it's saying it's volume, right? One of these can be x, one of these could be 3x plus 5, and then this could be 2x plus 3. That's really just asking you to factor. Okay, so same thing for this one on your own. Look for GCF and then factor. You probably don't need to use grouping just like we did up there, but see if you do. And then check back for the solution. All right, hopefully you got, this is your answer. The GCF was 2x, right? They all were even, and they also each had an x. So once you pulled that out, you're left with this. 30 times 2 is 60. 5 times 12 is 60 and adds to 17. So these split up, factored by grouping here. And then we got this as our answer. Okay, time for practice. Enjoy.